Hello, my name is Yanbo Wang, and this is my EE1 120 capstone design project. Um, so for the first part is the stakeholder interview. So the first stakeholder, I interviewed my friends, which is, which name is Paul Lee, and and so he suggests that returning to slow speed for a couple of clock cycles should be sufficient to cool off the system and resume normal operation. And the second one is Heren Liu, which is from another class. So he has more experience about this project. And so his suggestion is um like he suggests adding a visible cooldown indicator so the users know the system is recovering. And the third one is my dad. So she I mean he know nothing about the design and this kind of things. So so like his most interested part is the display behavior. So he wanted the display to clearly show what the state the processor is in at the all time and found the seven segment letters in intuitive. And for the next part, I guess I'll have to introduce my design, the first design. So for design one, I made three main assumptions. First, the system starts in a slow state when reset is asserted. And second, switching between fast and accelerated resets is consecutive high-speed counter. So one fast clock followed by one accelerated clock does not immediately continue the same overheating count. And the third one is the the only way to leave the arrow state is the asynchronous reset. Inputs alone cannot recover the system. So these assumptions make design one simpler and easier to verify in digital. And then I'll briefly describe both designs. So, so my two designs are functionally different. Design one is a simpler D flip-flop design with reset-only recovery from the arrow states. And design two is more realistic because it includes the cooldown recovery path. And in that design, the processor can recover from error by staying in slow mode for two clocks. Um, and speaking of this, I have to show you the scoring table. So the weighting criteria. So here. So to introduce this part, I'll like briefly tell you what I'm trying to say. So what I'm trying to say is design 2 scored slightly higher than design 1 because it has a better recovery features and real, more realistic. But however, um I chose to build design 1 in digital because it uses D flip-flops and use fewer states and simpler logic equations, which reduce the implementation risk. So like it's more easier to work on and it's more more clear clearly to show how it works. So the next part, I think I'll have to introduce the state table. So here for the design one, I have state S. State S stands for slow, and the encoding is 000. So the processor running at slow speed, and the 7sec output is S. And then the state D is default. The encoding is 001. So it's running in a default speed. So F1 is fast one, encoding is 010. So the the speed is um C equals 10, and this returns an F output. And F2 is fast 2, encoding is 001. So it's more faster than F1. And then state A1 is accelerate 1, encoding is 100. So the first consecutive clock cycle at accelerated speed C equals 11. And the 7sec output is A. And the state E is error, which encoding is 10101. So this means like the processor is overheated, system's locked, or something like that. So you have to exit. And those are unused because these are 8 states. I have only 6 states, but I use 8 bits. So the two are unused. Just like don't care. And the transition table, so it starts from S000, and then C equals 0, make no changes. But when C equals 1, it becomes 001, which is D. Yeah, here you go. So, and then C equals 10 is 10010, which is F1, and C equals 11 is A1 100, and and so on, I guess. So just basically the same things. And I'll go to design two. Design two is slightly different. The difference is this cooldown thing. Um, because I don't want the system to go overheat. So I added the cooldown states. So it takes like 7 states, and then the cooldown state encoding is 101. So the first slow clock after error, system is cooling. Display still shows E. Another slow clock returns to S. Yeah. And then the transition table, S E000, is just kind of same as this one, this design one. There's one different is this the cooldown state. And then so this part I've talked about it. Wait, did I talk about it? Oh yeah, so this is like how I get the weighting things. This is how I choose design one. I've introduced it, and this is my digital. So let's take a look at this. Um, it's a little bit big, I guess. So if I press start, and this is clock, this is C1, this is C0. So if I let C1 equals 1, and then the clock goes one time, the Q1 is 1, and then I press it another time, the Q0 is 1, and then the third time, Q2 equals 1, and then one more time, all of them are 1. And if I press C0, wait, I have to reset it. So if I press C0 and the clock first let Q0 becomes 1, and then so it's just basically not changing for the rest of the output. And then I guess that's it.喂，我有没有录到啊？